The first step is going to be keeping this side of the problem, but making this into 4 squared. It's the same as 16. So then I can set the exponents equal to each other in order to solve. So now I've got negative 2r minus 3 is equal to 2. And I'm going to go ahead and isolate the variable by doing the inverse operation of the constant, or adding 3 to both sides. And now I have negative 2r is equal to 5. And then we have to not only divide by 2, but divide by negative 2, because I don't want to know for a negative r, I want to know for positive r. So that'll cancel out, and I'm left with negative 5/2 is equal to r. We change this to 3 squared, so we can set the exponents equal to each other because of the same base. And then again, we're going to go ahead and solve this way. So we'll have negative 3x is equal to negative 1, and we can divide by negative 3. So x is equal to 1/3. 4 to what power gives us 64? So how many 4s do you multiply together to get 64? Pretty much. So this was asking us to evaluate. So in this case, it is just going to be equal to 3, because 4 cubed, or 4 times 4 is 16 times 4 is 64. So our answer right there. So yeah, it's still 3. 5 times 5 is 25, and then 5 of those is 125. So it is also equal to 3. I'm going to try to keep my variable positive when I can. So I add 2x to both sides, take away 10 from both sides. So I have 5x over here. It looks like it's going to be equal to 0. I'm going to go ahead and just set those arguments equal to each other already, but it's the exact same as this. So we're just skipping to step 2 right here. So negative 5n minus 5 is equal to 9 minus 4n. So same thing we did before. Let's go ahead and try to keep the variable positive. Add 5n to both sides, so end up with 1n over here. And then we also take away 9. So now we have negative 5 minus 9 is our negative 14. So 5n from negative 4n, we end up with just that. So now we've got our log base 13 of 24 is equal to v. So with our regular scientific calculator, what you have to do is our change of base formula in order to plug it in. So what's going to happen is our original base will go in the basement. So 13 will be the denominator, and then log of 24. So now it's base 10, so we can plug it into our calculator. So we'll have log of 24, and then divided by log of 13. Looks like it is approximately 1.239 and 0. We're going to divide both sides by negative 5. Write it as log base 18 of negative 89 over negative 5, or just make them both positive at that point. They'll just cancel out. So 89 over 5 equal to 8a. So we need to rewrite this using our change of base formula. So it'll look something like that, but then we'll also divide by 8 in our last step to solve for a. So let's rewrite it here. So we'll have log of 89 over 5 over the original base, which stays in the basement here, log of 18. So that whole thing, I'm also going to divide by 8 in order to get a. So let's go ahead and plug that into our calculator. So we've got log of 89 over 5, and then we're going to divide it by log of 18. So that should give you about 0.996, and then again we have to divide that by another 8. So our answer is A, or 0.1245. We split it up into 2, log x plus log y, and that's really all it was looking for. This one, because, well actually it's still multiplied, but the square root is the same as writing all of this, log base 5 of xyz to the 1/2 power. And when you're expanding or condensing all of this, the powers can be rewritten in the beginning, or if they were already here, you could rewrite it as a power or a radical. So now we'll have our 1/2 log base 5. You can also write it as log base 5 over 2 of x plus 1/2 log base 5 of y plus 1/2 log base 5 of z. Log base 4, and then all these things will multiply together. So there'll be a z, and then this 2 goes up here and makes it x squared, and this 4 goes up here and makes it y to the 4th. All right, so z times x squared times y to the 4th. So we have log base 4 of b, and then we have, technically that's supposed to go to the variable, sorry. So b times c to the 5th times the cube root of a. Base to this power gives us this, so we just write it as that. 16 squared is equal to 256. 9 squared is equal to 81. So base 8, so log base 8, that's our base, ready, it's equal to 8. So the only way that that happens is if it's to the first power. So again, it meets up with what we did from the previous problem. So 8 to the first power gives us 8. It also meets our definition of logarithms up there. So now, same thing, we will have log base 81, and then it equals 1/9. So the 1/9 goes right here, and the negative 1/2 power. So again, 81 to the negative 1/2 power gives us 1/9. And the way that would basically look is, instead of just having 81 and the square root of it, which would just be 9, they actually, you had to flip it. So you went from 81 over 1 and taking the square root to 1 over 81 and then taking the square root. So that's how you ended up with 1/9, is because it's not only a 1/2 power, it's a negative 1/2 power. X is equal to log base 2 of y to the 5th. So 5 log base 2 of y. And then you can divide this by 5, this by 5, and then you're left with, then you do all of this. So it's 2 to the x over 5 is equal to y. So, yeah, the only way you'll do 3 to the x minus 9 is equal to y. Start with a positive 4. So I have to plug that into the equation. So I'll have y is equal to log of 4 plus 4, and then minus 4. So log is the invisible base 10 down here of 8, and then minus 4. A negative 3.1 approximately. In this case, we can't use negative 4 because this has to be always, x plus 4 has to be greater than 0. So if we use like negative 3.5, that would work. So let's go ahead and plug that into our equation in our calculator. So this is approximately negative 4.3. So yeah, those are our answer choices. And well, we know that, again, x minus 1 has to be greater than 0. So the lowest x value that this can be would be like 1.1. So all the options where x is less than that, it can't work. So pretty much we know that, I guess, B and D already won't be an option because those negative x values would make the argument negative. So anyway, let's start with just one and see if we're able to pick out the remaining two options. So we have y is equal to log of 2 minus 1 minus 3. So pretty much it's just going to turn into, there's log the invisible base 10 of 1, and then we take away 3. You have 10 to some power, in this case 0 we just found out, is equal to 1. So obviously this part has to equal to 0, and then we take away our 3. So when x is 2, y is negative 3. Nailed it. And even the -2, it can't be that one. But our lowest x value, it could be basically, let's say we go just -0.5, because that's a pretty easy one. We could do negative like 999, but let's just go with that. And then if we need another x value, then it looks like 2 is a pretty good one. So our first one, when we go ahead and work this out, we'll have in our calculator log of 0.5, and the second one will be log of 3 we're looking at. All right, so for 22, it involves one more step because it's a different base. So we can still do it though. Log base 3 of x minus 1 minus 2. We look at our graphs, our possible x values look like they don't go any lower, and obviously we know why, but nothing is going to be past -1. So this needs to be x minus 1 is greater than 0. So kind of like we had before, we need an x value that pretty much is 1.01 or more, because if it's less than 1, well, this won't be greater than 0, in which case we'd have a negative in the argument of a logarithm. Go ahead and rewrite it using our change of base formula. So it'll be something like this. We'll have our log of 0.01 divided by a log of 3, and then we take away 2 is equal to our y value. So let's go ahead and take a look at that. We've got 1, and then you take away 2, and now you've got -1. So when you do y is equal to 1/4 times 8 to the 0 power, it's just the same as multiplying this by 1, right? So now we have 1/4 times 1. So whenever x is 0, that y-intercept will be whatever you're multiplying by. When x is 1, we have y is equal to 1/4 times 8. So basically we have y is equal to 2. And technically if we did want to do x is 2, it would be 16 units that we were able to find. Let's go ahead and do 2. So when x is 2, y is equal to 4 times 2 squared. So y is going to be equal to 4 times 4, or 16 here. Y is going to be 1/3, just because of how these graphs work with the exponents. So now if we choose another value, let's go ahead, let's say we do x is equal to 2. So now we've got 1/3 times 6 squared, or basically we've got our 36 over 3, or 12. 0, we've got obviously y is 2, x, I guess we're going to go ahead and pick 2 again. So we've got y is equal to 2 times 2 squared. So y is equal to 2 times 4, or 8. But it's important to remember just how they actually work out. So the initial value will always be 263,800. So that's why it was included in all the answer choices. I didn't expect anyone to get that wrong. But depreciating means you're getting the initial amount, 1, minus your 10%. So it had to be 0.9. You weren't adding it. It wasn't getting larger. Cars depreciate. They lose their value over time. So that's just something you should keep in mind that we actually talked about on day 1. So this was the value of a particular Lamborghini, and it was getting smaller. So just so you know, this is the same as 0.9. It's like a decay, exponential decay. It is a number smaller, or a base smaller than 1. So all of that was to the time power. In this case, I said 5 years, but when you had to write the formula, you just had to write t. When you solved it and plugged it into your calculator, well, you would go ahead and write this whole thing again, boom, and then to the 5th power. So the answer there was D, and it was about, after 5 years, a $263,000 Lamborghini would cost about $156,000, give or take. We've got something that's leet, and then you go ahead and increase it by 2.7%. So it's 1 plus, and then 2.7%, if we write it over here, percent. We have to convert it to a decimal, so we divide it by 100. Or we take 2.7 and we move it over 1, 2 decimal places. And so now it's 1 plus 0.027, and then it says 93 to 2012. So our exponent of years will be 19. So at the end of the day, you should have gotten, when you plug that into your calculator, 22, 180, and 42 cents. This turns into 3,500, and then you've got 0.71. So that's really the only option it could be. It can't be C because you forgot the initial amount. So if you would put just a 0.29 inside the parentheses, you're representing a 71% decrease, not a 29% decrease. So then you do this to the third power for the 3 years, and you're left with 1253 animals after that period of time. Something over 9,000 after 15 years. So what's our initial amount have to be in order for something 4% after 15 years? So that would be the equation you use to set it up and solve for x. Ultimately, you're going to have to divide something over 9,000 by all of this in order to get x, and your final answer would have been 49.97.